Hi everybody. So far you have learned about piecewise functions and the point slope form. So now we're going to continue our learning and look at how this all looks in a context. So in this context, you're going to see it being about a bike ride. So below is a piecewise function that estimates the total distance, which is d of t for your y-axis in miles. They travel in t hours right here, which is your x-axis, during their bike ride. So over here, you can see that this is our piecewise function. So here you see the intervals, our domain, and here you see our functions. Now you notice that the first one is written in y equals mx plus b form. So you would usually see that this could also say plus 0. So we know that we're starting at 0 for our y-intercept. So over here is our 0, and it's saying that our slope is 16. So we would go over 1 and then we go up 16. Okay, so that's our first part. So we can connect these at a later time. Now the next part you can see right here is 1 and 16. So here's our next point, 1 and 16. And we know that our slope is now going to be 6. So we go over 1 and we go up 6. So we go 2, 4, 6. Here's our next point. The next part is 2 and 22. So here we are at 2 and 22, and our slope at this time is 14. So we go over 1 and we go up 2 at 14. So 2, 4, 6, 8, 10, 12, 14. So we should be at the point of 3 and 36. Let's check this. We're at 3 and 36. And now our slope is supposed to be 8. So we go over 1 and then go up 8. 2, 4, 6, 8. And then this is our last part right here. So we can take our connector and connect our piecewise function right here. And last one. All right, so here's our piecewise function. Now for the next part, it's asking us a few questions. So it's asking what part of the bike ride do they go the fastest and the slowest, and how do you know? Well, this really depends on your part of the slope. So if you're looking at the slope, you're looking at, well, which really increased the most within possibly an hour time frame, and which one increased the slowest. So if you're looking at the first part, within the first hour, they increased from 0 and they went all the way up to 16. Okay. And then this part, this one seems like it went up pretty fast. Let's look at this. This went up from 22 to 36 within 1 hour. So that's 14. So that means that this part right here really is the part that went up my fastest. Okay, so from here to here is my fastest. So fastest from 0 to 1, and we can say that that was 16 miles. Now my slowest would be either way, this part or this part right here. So if we're looking from the first hour till the second hour, we went up from 16 to 22. So that means we went up 6. Okay, let's see what happened in from 3 to 4 hours. So that went up from 36 to 44. So that would be 8. So really, this part right here would be the slowest. So the slowest is from 1 to 2. And we said that that was 6 miles. Okay, so the next part is is asking about the domain of this function. So the domain of the function, remember, it's asking you about your x values, which in this instance is my time in hours. So if you remember, we started at 0, but we're ending over here at 4. So that means it's anything from here until here. So that means my domain is 0 is less than or equal to x. Or in this instance, we could also write t, because we're talking about t in hours, less than or equal to 4. You could also check in your intervals and your piecewise functions. So this is all starting at 0 and ending at 4. So that's another way of looking at it as well. And now our next part, it is asking what d of 2 is. Explain what it means in terms of the context. So there are a couple ways you can figure this out. The first way is you can look at the function, right? So you're looking at d of 2, so that means at 2 hours, how many miles did they travel? Well, that's going to relate to 22. So 2 and 22 is my point right here. So we can say at 2, after 2 hours, they traveled 22 miles. Another way of looking at this is also to plug in the 2 into the function. So the thing is, this is happening at 2 hours. So could I plug this in the last part? No, because that would be right here, and this has nothing to do with our 2 hours. So what I would have to do is I would have to see where the 2 in my domain is, which could be right here. And I would write this down, and I would plug in 2 for my t. So I'm going to take 6 t minus 1 plus 16. And that would be d of 2 equals. Then I'm going to go ahead and plug in my 2. So that would be 2 minus 1 plus 16. And I'll go ahead and continue to simplify. Well, 2 minus 1 equals 1. So that would be 6 times 1 plus 16. And I'll continue. That would be 6 plus 16. And here I also get my 22 miles. So either way and either strategy is okay to use. You can look at the graph if you have it, but if you don't have the graph, you really need to be able to know how to plug this into your piecewise function. So the same thing happens here with 3 hours. So it's asking you how many miles they traveled after 3 hours. So we're looking at 3 hours here, and if we go up to 3, my 3 would correspond to 36. So this would be 3 and 36. So they traveled 36. So here we can say after 3 hours, they traveled 36 miles. And if I put this in function notation, it would be d of 3 equals 36. Remember, this is called function notation. Okay? Now my last part is asking us about the total distance they traveled on this bike ride. So remember, my y-axis tells me about my total distance. We started at 0, which was right here, and then they went all the way up to here. So after 4 hours, they were all the way up here, which corresponds to 44. So they traveled from 0 all the way to 44. So we can say the total distance traveled was 44 miles. Alrighty.